Today we will continue the topic of stereochemistry which were remaining in the first video of this series. So, ring chain isomerism. Compound possessing open chain and cyclic structure but having the same molecular formula are called ring chain isomer, and the phenomena is known as ring chain isomerism. You can see in this example propene and propane. Both of them have the molecular formula C3H6, but their propene is open chain and cyclopropane is cyclic. So these two are the isomers. Suppose in one of the example the number of pi bond is X in open chain, then in cyclic compound it will be X minus Y, where Y will be ring number of rings. So we will see in this propyne and cyclopropene. In propyne there are the number of pi bond is 2, and in cyclopropene we will calculate by X is 2 and number of ring is 1. Therefore over here the number of pi bond is 1. In this way we can calculate the number of pi bond in cyclic compound by knowing the number of pi bonds in open chain. So moving on to metamerism. What is metamerism? Metamerism is a type of isomer in which the compound having same molecular formula but different alkyl group on the either side of the functional group. It is only possible in the bivalent groups such as oxygen, sulfur, NH, CO, etc. We will see some examples. In this example, the functional group of the bivalent compound is oxygen. Over here the bivalent atom is oxygen. So on the either side of the bivalent oxygen, over here there are 2 carbon atoms and 2 carbon on both the sides. But in the isomer of this, on one side we have 1 carbon atom, or on the other side we have 3 carbon atoms. So these are the isomers, and these isomers are known as metamers. Metamers can also be positional isomer. You can see in this example pentane 2-one and pentane 3-one. These two are positional isomer. It is also meta-isomers, but the first preference is given to positional isomer. So we can see it is as a positional isomer. Over here the ketone position is the second position, and over here third position. So how it is metamers? Let's see how it is a metamer. In ketone, on this side there we have 1 carbon atom, and over here we have 3 carbons. In second isomer we have 2 carbon on one side and 2 carbon on the either side. Therefore it differs in the number of carbon atoms on the either side. So we have seen all the constitutional isomers. Now moving on to stereoisomers. Stereoisomers are of 2 types, configuration and conformational. Now we will see in detail configurational isomers. Stereoisomerism is exhibited by the isomer having same structure but differing the spatial arrangement having configuration. Because configuration is possible because of carbon atom mainly covalent bond. Geometrical isomerism. Geometrical isomerism is characterized by the compound having same structure but different spatial arrangement of the groups around carbon-carbon double bond. In this compound, the free rotation is not possible because of this double bond. This double bond blocks the rotation, so it cannot be rotated. Geometrical isomerism can only be exhibited in unsaturated compound and cyclic compound. Isomers. The isomers we having the same groups on the either side of on the same side is known as cis isomer, and having the similar groups on the either side of the opposite side is known as trans isomers. The prefix cis and trans is given to these isomers. So, how we can calculate the number of geometrical isomer in a molecule? It is given by 2n, where n is the number of double bonds. For example, 1-phenyl, 1,3-pentadiene. In this compound, we have two double bonds. Therefore, 2 raised to 2, which is 4, means this compound will have 4 geometrical isomers. Geometrical isomerism is also shown by oxime, in which there is a double bond between carbon and nitrogen. You can see here in this example, carbon and nitrogen double bond, and carbon also double bond. In the nomenclature of the oxime, the prefix syn and anti are used instead of cis and trans. The isomer in which the hydrogen and the hydroxyl group are on the same side is known as syn isomer, and in which the hydrogen and the hydroxyl group are on the opposite side is known as anti-isomers. In this example, it is a syn benzyl doximide because the hydrogen and hydroxyl group are on the same side. In this, hydrogen and hydroxyl group are on the opposite side, so it is anti-benzyl oxime. Geometrical isomerism is also exhibited in cyclic compound. The ring takes place of a rigid double bond and restrict the rotation of the carbon-carbon atom about their axis. So over here the carboxylic acid group are on the same side. Therefore, it is a cis 1,3-cyclobutane dicarboxylic acid. Over here, the carboxylic acid group is on the opposite sides. Hence, it is trans 1,3-cyclobutane dicarboxylic acid. Thank you for watching this video. Hence, subscribe and press the bell icon for more such content.